What's up, guys, and welcome back. Hopefully you and your families are all safe and doing well. All right, in this very quick and easy, probably even less than 10-minute video, I want to talk about understanding scatter plots. All right, and basically what I'm going to show you guys is I'm going to show you how easy it is to analyze scatter plots and the data sets that make them up. And then, of course, as always, we will look at how scatter plots show up on the regions and how easy they are to answer them on the regions and get them correct. So basically, guys, when you're talking about a scatter plot, you are talking about a graph that relates two different sets of data and is used to find trends within that data. So right here below is a perfect example of a scatter plot. Okay, notice when you have a scatter plot, it's graphed on in the first quadrant of a graph. All right, and one data set would run along the x-axis. The second data set would run along the y-axis. Okay, and what you have here is ordered pairs or plots, right? And they're going to trend a certain direction. And notice in this particular scatter plot, the ordered pairs or the plots are trending upward. Okay, and when we want to talk about kind of how one data set affects the other data set, when we talk about that, that's when we want to look at a very important word that is going to come up on the regions, and that is called correlation. All right, now correlation is basically the relationship between two different sets of data, and that's what the scatter plot is going to show you. All right, now there are three types of correlations. The first type is called a positive correlation. In a positive correlation, guys, both sets of data increase. The data always, always, always trends upward. So for example, you have a scatter plot right here. Along the x-axis, we're looking at the number of family members. On the y-axis, we're looking at the grocery bill, how much you spend on food. Notice, as you go along, the ordered pairs, guys, the trend of the data is increasing. And what you can do is you could even draw what we call a trend line. All right, so if I were to draw a trend line, and bear with me here, I'm doing this on a, but it's going to look like this. Notice my trend line. Now, obviously not perfect. It could be a little bit higher, but it doesn't really matter. For the purpose of this graph, notice my trend line, guys, is increasing. That is why we call this a positive correlation. This is what a positive correlation is always going to look like. And if we were to evaluate this, guys, we would basically say, as the number of family members increase, the grocery bill also increases, right? And if you look here, a family of two costs around a little bit over $100 around for groceries. Then look at a family of, say, 8 or 9. Now it's much more expensive, $350, $400 for groceries. So that's basically what this scatter plot is showing. As family members increase, the grocery bill also increases. This is always what a positive correlation looks like. Next correlation is a negative correlation. As one data set increases, the other data set decreases. Data always, always, always trends downward. Okay, so if we were to once again draw our trend line, well, it's going to be looking like this. Notice the trend line, guys, is going downward. Notice the ordered pairs are trending downward. Okay, that is a negative correlation. So basically we're talking about 3-mile running times, right? How long does it take to run 3 miles? On your x-axis, you're looking at the weeks you have been training. Training for 1 week, training for 4 weeks, training for 8 weeks. And then on the y-axis, we're looking at how long it took you to run. 20 minutes, 24 minutes, and then of course, 30 minutes. So basically what this graph is saying, as the weeks in training increase, right? As the longer you train, the run time in minutes will be decreasing. And that is what this scatter plot is showing. Notice the ordered pairs are trending downward. That's why we call this a negative correlation. Okay? The ordered pairs are always trending downward. This is what a negative correlation will always look like. And finally, guys, the third and final or last correlation is called a no correlation. Within a no correlation, guys, there is basically no relationship between the data sets. Okay, so here along the x-axis, we have the number of peanuts eaten. And along the y-axis, guys, we're talking about bowling scores. And basically, notice how the ordered pairs are kind of all over the place. Nothing is trending upward, nothing is trending downward. They're kind of going all over the place. This is because there is no relationship, or what we talk about when we say, or what the Regents will use as no correlation. No relationship between the number of peanuts you eat and the bowling score you get. And that's basically what this scatter plot is showing. Eating peanuts does not affect the bowling score. So guys, that is basically it for your correlations. There's a positive correlation, everything trends upward. There's a negative correlation, everything trends downward. And then of course there is a no correlation. So now let's look at some Regents questions. Regents question 1. The scatter plot below shows the points scored and the points allowed by the Titans soccer team for several games. Which, and now notice what the Regents does here, which sometimes they will use the word association. Guys, association is the same exact thing as correlation. It's just their way to try to throw you off a little bit. Which association correlation best describes the data? Well, if you notice, the ordered pairs, guys, they are trending downward. If you draw your trend line or your line of best fit, it is trending downward. Therefore, we know, based on the ordered pairs trending downward, based on our trend line trending downward, this is a negative association or correlation. So basically what we're saying here with this graph is, as the points scored increase, the points allowed, which is what the y-axis is, decreases, which is your negative correlation. All right? Regents question, simple, no work needs to be done. Let's look at one more. Second Regents question. The number of hours spent on math homework during 1 week and the math exam grades for 11 students in Miss Smith's algebra class are plotted below. Based on the plotted data, what is here's the word that the Regents uses, correlation between the time spent on homework and the exam grade. Well, here's what you have. Notice, guys, the ordered pairs. If you were to draw a trend line, right, they are trending upward. The ordered pairs are trending upward. Your trend line is trending upward. Therefore, what type of correlation always trends upward? Positive, guys. Simple. Boom. You are done. So basically what this scatter plot is talking about is, as the time spent on math homework increases, the exam grade a student gets also increases. That is what we call a positive correlation. And guys, that is basically it. That is scatter plots on a Regents exam simple. All right, so that's basically it for scatter plots, guys. Download the notes and worksheets so you can work on it. Comment below on what you liked, what you didn't like, what you want to see. Any questions at all from me, please email me at bwritingcihs@yahoo.com. Please subscribe, share, and like. And as always, folks, as always, thanks for watching, and continue to please stay safe. Scatter plots on the Regents, easy. Get it right when you see it.